Welcome back, mathematicians. In this video, we are going to learn about symmetry with respect to the origin. So I have a graph that is symmetric with respect to the origin, and this one is probably the hardest to visually determine because unlike the x-axis or y-axis, there's no vertical line of symmetry or horizontal line of symmetry, but it is symmetric with respect to the origin because for every point x comma y on the graph, there exists a corresponding point that is the opposite x value and the opposite y value, which is also on the graph. And that is true for every graph that is symmetric with respect to the origin. And that leads us to our algebraic test. So for this test, we are going to replace x with negative x, or the opposite of x, and y with negative y, or the opposite of y. And then our goal is to simplify. So what we're trying to do is simplify this equation once we replace x and y with negative x and negative y to see if we can go back to the original equation. And if we can, then that equation represents a graph that is symmetric with respect to the origin. If we cannot, then the graph is not symmetric with respect to the origin. We are now going to use that test to determine whether the graph of each equation is symmetric with respect to the origin. So we are going to replace y with negative y and x with negative x using parentheses anytime we do substitution. And so our equation now is negative y is equal to negative x quantity squared minus 4 all over 2 times negative x. I'm going to rewrite the y without parentheses, and there's nothing I'll do with that y for the moment. And the right side, negative x quantity squared, is really negative x times negative x, and then minus 4 all over negative 2x. So now I'm going to go ahead and simplify negative x times negative x, which is a product of positive x squared. So now I have negative y is equal to positive x squared minus 4 all over negative 2x. Well, now I'd like to go ahead and multiply by a negative 1. And to do this and to understand how and why that works, I'm going to put the numerator in parentheses. And as I just mentioned, I'm going to multiply both sides by negative 1 to see if I can go back to the original equation. I'm allowed to do this because I'm doing the same product on both sides of the equal sign. Well, what happens is that the negatives cancel out on the left, leaving me with just y, and on the right, the negative 1 cancels out with the negative coefficient of the denominator, which leaves me with x squared minus 4 in the numerator and positive 2x in the denominator, which means I was able to simplify back to the original equation. So the test passed. What this means is the graph of this equation is symmetric with respect to the origin as a result of the test passing. So let's go to our second equation, and repeating this same process, I will have the quantity of negative x squared plus negative y minus 9 is equal to 0. Well, we just saw that negative x quantity squared is positive x squared, and there's no way to simplify the y term, so I'll just rewrite it as negative y, or minus y, minus 9 is equal to 0. Now, sadly, there's nothing I can do to both sides. There's nothing I can do to simplify the left side in order to get back to the original equation. So this, unfortunately, fails the test. This means that the graph of this equation is not symmetric with respect to the origin. Let's now look at each equation and its corresponding graph to validate that the test is correct. So in the first equation, we saw that the test passed, which means that the graph of this equation should be symmetric with respect to the origin. And we see that that is true. We see points that are opposite. We see points that are on opposite quadrants of our coordinate plane. And I'm just highlighting a few here to show that these points, these corresponding points, do represent an ordered pair that is x comma y, and an ordered pair that is the opposite of x and the opposite of y. Let's now go to our second equation, which is x squared plus y minus 9 is equal to 0. And as we see, we have a graph that is a parabola. And if this were symmetric with respect to the origin, we would have a point right here on the graph, which is x comma y, and then a corresponding point in the third quadrant, which would be negative x comma negative y. Well, that point should be about there. That gives me about the opposite x value and the opposite y value. Unfortunately, that is not a point on the graph, so we can visually see that this is not a graph that is symmetric with respect to the origin, which validates that our test did fail. All right, guys, good luck.